So once we have identified A and B, then rest of the thing will be a cakewalk for us. Now, and we can't go in this path because D is being added on G and D is here. So first we'll have to identify what is D. Let's go on finding out C. Now B, I know B is a Grignard reagent. I'm adding Grignard in Grignard reagent carbon dioxide gas, and we have seen a moment before when you add carbon dioxide gas in Grignard reagent followed by protonation, that will result in a carboxylic acid, and since we are having pH here, that will result in benzoic acid. Now this acid is a very common and important acid. In case you are not aware of the name of this acid, then I will recommend you to remember the name of this acid here itself. This is benzoic acid. Commit this thing to your memory. This PHCOH is benzoic acid. Now this C is benzoic acid. We have got C. Now from C to F, if you look around, now this reagent, the CaO, NaOH and delta, this reagent is the reagent for soda lime decarboxylation of any carboxylic acid. Now this reaction we studied when we studied hydrocarbons, particularly when we studied alkanes. This was one of the method of preparation of alkanes. Now the beauty of this organic is the reactions are linked with each other. You can get any functional group starting from any functional group. At the end of the syllabus, I'll show you we can prepare any product with any functional group beginning with any substrate having any functional group. So this thing will be the continual phenomena of the course. I'll be taking in the reactions from the previous chapters so that you don't miss on anything, and the link proceeds so that when you go to your examination hall at the end of the course, all the reactions gets engraved in your mind, and really at the end you will realize that you need to get an impetus to start with this course. It's to start with organic chemistry, but once you start getting tuned yourself, then it becomes very easy, and you don't forget. Never ever you'll forget in life, because it has been 5 years since I studied these stuffs, and I don't have to revise, I don't have to prepare for the lecture. Things are there safe enough in my mind, and it does not get wiped off. Once you understand it, it's so scientific that you will get addicted to it. It's so interesting, and things will become very easy. You will see that same things happens in every reaction. Understanding the reaction mechanism will not be tough. You'll see, you'll observe in each and every step. What you have to do is you have to search for electron rich species, you have to search for electron deficient species, and then you have to start electronic transition in between them. There are certain driving force like aromaticity, like C double bond O, like removal of very stable groups. These things governs the reaction, and having a clear understanding of these things, one can work out the mechanism of any kind of substrate with any kind of reagent. This will be the idea of the course, and to facilitate the understanding, we have to solve these kind of conversions, because in my belief these are the only way out to memorize the reactions. Now C we have identified. Now this reaction is soda lime decarboxylation, and we know what the soda lime decarboxylation is. Effectively it removes off this carboxyl group, this carboxylic acid group, as carbon dioxide gas. So this CO2 gets removed off, and this pH and H will get bonded. That will result in benzene. So it's clear enough for us to understand that F is benzene. Now when you go, now look at the arrow properly. Don't think that I have committed any mistake. This arrow has a proper correct direction. Arrow is from D to C. That means C is prepared when we are doing hydrolysis on D. Now C is carboxylic acid. On doing hydrolysis of some functional group, I'm getting a carboxylic acid. Now that some functional group as such can be any acid derivative, but to zero down to one particular functional group, I must add here, or I must tell you here, because I haven't given you any other hint, I must tell you that when you hydrolyze D, you get C, and apart from C you also get ammonia gas. If I add this information, then you will have a unique functional group that will do it, and you add this information, or you just know this information in order to solve this D, in order to get D a unique compound. D, when you hydrolyze D and you get C, you also get ammonia gas along with this. So write this statement along with this conversion problem. So in that case D cannot be anything other than cyanide. We have seen that when you hydrolyze cyanide, you get carboxylic acid. When we studied hydrolysis of different functional groups, we studied this. Although we didn't see the mechanism, the proper place to see the mechanism of this reaction is the chapter carboxylic acid and its derivative, where we will be studying the preparation of carboxylic acid. They will see this method as one of the strong method to prepare carboxylic acid, and there we'll see the mechanism of it. But for the time being, you must know this, and I hope you already retain this information in your mind, that when cyanide is hydrolyzed, you get carboxylic acid along with the evolution of ammonia gas. So in that case, D will be a cyanide. D will be a cyanide such that instead of this carboxylic acidic group, you will have a CN group, you have a cyano group, and rest of the structure of the substrate will remain the same. So to write the structure of D, you just have to look at the structure of C. This pH will remain as it is. This pH will remain as it is, and this, instead of this COOH, will have C triple bond N. That will be benzonitrile. So this benzonitrile is D. If you hydrolyze this benzonitrile, you will have C, that is benzoic acid. We proceed ahead. On D you are adding B, and B already we have found out as a Grignard reagent. So, and D is a cyanide, and we have seen the reaction of Grignard reagent with a cyanide that will result in formation of ketone. So here the Grignard reagent will attack on this carbon. This carbon is electron deficient. That will result in generation of negative charge on nitrogen, and subsequently when we hydrolyze that substrate, that negatively charged substrate, the hydrolysis will occur, resulting in formation of ketone and removal of ammonia gas. Since here I have given you only one product, you will consider that product as the organic product. We will not write E as ammonia, because that is an inorganic entity. So whenever you will have, in reaction, suppose you have evolution of certain kind of gas, you have a side product, and in case you have been given only one product, as I have given here, then you report that product as the organic product that you are getting, and the organic product in this reaction will be ketone and not ammonia. So E will be ketone. To write the ketone, on one side of that ketone you will have the group same as that you have in case of cyanide, that means pH. On the other side of the ketone, the R group which is present in the Grignard reagent, that will come, as we have seen how to write the product. And B is the Grignard reagent having R as pH minus. So one of the pH, on one side you already have pH, on the other side again you will have a pH. So you will get a ketone like this. This pH, C double bond O, pH. Now this is an important ketone, and the name given to this ketone is benzophenone. You have to know this name. Later on in the conversion, I will not draw the structure anywhere. I'll just give you the name benzophenone, so your examiner will do in your exam, in the question paper. This is an important name, so you have to know this. This is benzophenone. So this ketone, when you have pH on both sides of carbonyl group, that is benzophenone. That's called benzophenone. So you have identified E. E is benzophenone. Now the only thing that is left to identify is G. Now in G you are adding D on B. B we know, B is a Grignard reagent. D we have identified, B is a cyanide. So what will happen is, basically this is the same reaction. You are adding B on D here, and you are also adding D on B here. So G again will be a benzophenone. So G effectively is same as E. So G is benzophenone. So this was a very tiny conversion based upon the immediate reactions, except this soda lime decarboxylation that we have seen just in the last section. So these are the reactions. You must be able to convert this kind, or find the products in this kind of conversions. You note down the conversion, make a note of it, you note down the answer, and after some days you practice this out. You must get the right answers of all the products. You must keep revising, otherwise organic will evaporate out soon. and when you keep on revising, it gets consolidated, then it becomes permanent in your mind. If you don't revise, I bet you are going to lose on this.